to talk pyramids now. Remember I told you that there are two base kinds of shapes. What we've talked about first, those are all the prisms and cylinders. Prisms and cylinders have two bases. When I'm going to talk about pyramids and then tomorrow cones, the main difference is that each of those shapes only has one base. We have a couple vocab words that are going to be a little bit different when we talk about pyramids and then later cones. So let's take a look at all of these vocab words. Most of them are the same things we talked about for prisms. We have bases, edges, faces, and then specifically, the very top of my pyramid is going to be called a vertex. Okay, that's a big word for us. And then remember how I kind of talked about altitude. Altitude and height mean the same thing here. Height for pyramids are going to go from the vertex, the very top, down through the middle of my shape, and they make a right angle, or they are perpendicular to the base. We're still going to use these quite often. They're going to be labeled in my shapes. However, in my formula, we're not going to end up using this height. We're going to use a different kind of height, and this is the big vocab word that I need you to take away. It is called slant height, and it is this guy right here. Slant height is the distance from the vertex down to the middle of the base edge. So these two pieces of the base are congruent, where it splits it in half, but it's going like down the side. So I have this little shape here. It's nothing fancy really, but it does provide a nice little visualization. You can see, do you see how the string goes through the middle? That's height. But then when I move the string off to the side, it's now slanted from the top to the edge. That is slant height. If you want to play with this shape, you can play with it later. But that's the big difference that we have to keep in mind. Any questions? Height goes down the middle. Slant height goes down the side. Okay, fantastic. So we're going to figure out what our formula is by first finding it with a net. Remember, we don't want to use nets every single time because it's going to be way too time consuming. But for the purposes of figuring out what my formula is, let's go ahead and draw a net. So I'm going to start with the base. That base has 5 sides. Remember, we name pyramids the same way that we name prisms, by the shape of the base. So this would be called a pentagonal pyramid. I'm going to draw that pentagon out. And then I'm going to draw all of those lateral faces. For pyramids, our lateral faces should always be triangles. So I'm going to draw all those lateral faces here. There it is. Oh, that was so uneven. Okay, let's add some labels in. The base has side length S. Oops, I want a different color. The base has a side length of S, so I'm going to label this guy as S. And we see this curly L. That's one of our new terms here. That L stands for slant height. And again, it's going to go from the top of my shape down to the edge of the base where it's making a right angle and it's splitting that in half. And I'm going to call this right here L. Okay, cool so far with my net. Now let's figure out the surface area of this net. So the surface area here is going to be the area of each one of these triangles. So let's say area of the triangles plus the area of, I just have one base, so it's the area of just B. Now, I'm going to kind of do this in a weird way so that we can get to our formula. The area of those triangles, in this case, I have 5 triangles, but I might not have 5 triangles every time, right? The formula for a triangle is 1/2 base times height. I'm just going to write it twice, and then I'm going to use an ellipses to show that there's probably a lot of them. 1/2 base times height plus 1/2 base times height plus however many of those triangles I have, plus the area of one base. Let's call that big B, because in this one it's a pentagon, but it might not always be a pentagon. I'm going to do a little bit of math here. Oh, wait, actually, sorry. I'm going to substitute in some numbers. So instead of base of my triangle, I'm going to call that base S. Oops. Let's get red. So I'm going to rename this 1/2 S. What the heck? 1/2 S. And then instead of an H for height, I'm going to use an L for slant height. Okay, good. And now, okay, here's where some little woo-woo algebra comes in. I'm going to take out a GCF of 1/2 L. Follow me here. Which leaves me with just S plus S plus S plus S until I do all the sides. Stay with me. Follow. Okay. And then if I think about what is S plus S plus S plus S, all of the sides added together, that's my perimeter. So here's where my formula comes in. My formula is, for surface area, 1/2 perimeter times L for slant height plus B. I know, that was a lot of weird algebraic movements I just did, but I'm trying to prove to you where this formula comes from so that you can see where all of those numbers are. Okay, good. That's our formula. That's going to be number 13 on your blue sheet if you want to fill it in. Okay, when you're ready, go ahead, flip it over. We're going to look at these examples. All right, the first thing that we should do is we should look at this shape and we should name this shape. What are we going to call this shape? I need to look at the base. I need to look at how many bases there are. If there's 2 bases, it's a prism. If it's 1 base, it's a pyramid. Caitlin? Octagonal pyramid. Perfect. It's octagonal because that base has 8 sides. It's a pyramid because there is only 1 base. Here's the base. Okay, good with that? I'm going to fill in the pieces of my formula. Lateral area, remember lateral area is all of the sides not including the base. That's 1/2 perimeter times slant height based on my formula. B is just whatever shape the base is. Okay, that base is an octagon. What's my formula for finding the area of an octagon? It's on your sheets. Regular polygons use what formula? Caitlin? Perfect. Okay, those are all of our pieces. The lateral area is 1/2 perimeter times slant height. The area of the base, we're going to use the regular polygon formula, 1/2 apothem times perimeter. So let's start plugging some stuff in. 1/2, the perimeter of this base. There are 8 sides, and each of them is 6 centimeters long. So 8 times 6 is 48 for that perimeter. And then slant height. This is our new vocab word. I got to find the piece that goes from the very top down the side to the middle of one of those bases. So that's that blue line I just drew. It's 18 centimeters because that's what it's telling me it is. Then I have 1/2 apothem times perimeter. Many times you're going to have to find this apothem yourself, just like we did in the last unit. In this case, it is already given to us. It's 7.2. And we already know the perimeter is 48. Don't waste your time trying to solve this by hand. Just plug it into your calculator. I'm going to end up with, in my calculator, 604.8. I want to make sure I add a unit on there, so centimeters squared. Questions on that? Okay. Number 2. I gotta look, I gotta find the base. How many bases do we have? What shape is the base? Let's name this figure. Oh my goodness. What is this called? Why are my pages overlapping? What is this called? What the heck? There it is. Dahlia? Triangular pyramid. Perfect. What side of this shape is going to be my base? What are we going to choose for my base here? It's usually the one that's on the bottom. Not all the time, but in this case, it is the one that's on the bottom here. So here's the base. Lateral area, 1/2 perimeter times slant height. And then this base is a triangle. Specifically, it's an equilateral triangle. All 3 of these sides are actually congruent. What's my formula for this triangle? The area of a triangle. I have 2 options. Give me one of them. How do I find area of an equilateral triangle? What's the formula to find the area of any triangle? Anna. Perfect. We have a formula specifically for regular equilateral triangles. What is that one? For any regular polygon, we can use... Kaylin? Perfect. For equilateral triangles, we can use either one. It's really your preference whether you like 1/2 base times height or 1/2 apothem times perimeter for this. It's going to be the same amount of work either way, let me tell you. Okay, so let's start with the lateral area. I want 1/2 the perimeter of this base, 6 plus 6 plus 6, oh gosh, is 18. And the slant height of this shape, again, goes from the top down the side. That's an 8. Okay. Then for my base, 1/2. And I'm going to draw this base out, like from a top-down view so we can see. There's that base. Now, if you really like apothem and perimeter, then go ahead and draw your apothem in. Put that down there. You'll know what kind of triangle is in there. It's a 30, 60, 90 because it's a special right triangle. You can solve for the apothem. We already know the perimeter. If you want to do that, go for it. I like base times height here, personally. That's just my preference. That's what I'm going to do. You can also draw in a triangle here. That's a right triangle. Because it's equilateral, I know that's 60, so this is 30. And again, same thing. Special right triangles. Here's 3. That apothem then is 3, radical 3. Or sorry, not the apothem. The height of my triangle. And then the base of my triangle is 6. So I did 1/2 base times height here. If you want to do 1/2 perimeter times slant height, 1/2 apothem times perimeter, go for it. Okay. Plug it in to your calculator. I got 87.6. And we are in feet squared. Any questions on that? Okay. Alrighty. Go ahead, look at the next one. They love these kinds of problems. So a lot of the time, it's not just going to be so straightforward where they give you every single piece that you need. If I take a look at this particular pyramid, I can see the only two things that they gave me are the slant height and the altitude, the actual height. Okay? What is this shape called, first of all? It is a pyramid, I'll give you that. What kind of pyramid? The shape of the base is a... What shape is the base, Caitlin? It is a square pyramid. This is a square pyramid. Okay, beautiful. So here's my base. And for that base, I don't know any of the side lengths. That's going to be a problem for me in a second. So let's first write out my formula. Lateral area is 1/2 perimeter times slant height. The area of the base is going to be side squared. Any ideas for how we're going to do this? How am I going to figure out what the length of that side of the square is? No takers? Okay. We're going to do this quite often. I'm going to draw in, or I'm going to highlight here, my slant height. Can I do this in the right color, please? My slant height here. Oh, gosh. My actual height. And then this goes from the center to the edge of my square. That's the apothem. Slant height, regular height, apothem make really, really nice right triangles. So if I already know in this right triangle, the hypotenuse is 25, the regular height, the long leg is 24, and then this bottom, that short leg is x. I'm going to use Pythagorean theorem here to figure out what that x is. X squared plus 24 squared equals 25 squared. Maybe you already know that that's a nice Pythagorean triple. We're going to end up with x equals 7. Okay, you still with me? If that x is 7, that's going from the edge of the square to the center of the square. I have 2 of those little segments. So if both of them are 7, one side of my square is 14. Yeah, still with me? 1/2. The perimeter then is 4 times 14, which is 56. The slant height of my shape is the 25 that it gave me. And then one side of my shape is 14. So this is going to be 14 squared for the area of that base. Plug it into the calculator. I got 896. It's not meters, it's units. Any questions on that one? One more. Here's our composite figure. You know these are going to be on your homework. I'm thinking about taking these 2 shapes off separately. I feel like that's been a little bit of a confusion. When we talk composite figures, I'm finding the surface area of each one separately, and then I'm considering what is actually being shown from the outside. So the surface area of the top figure is what we're going to do first. The top figure, in this case, it has one base, and that base is a square. So this is a square prism. I want the surface area. Surface area of the square pyramid. However, if I think about finding the surface area of that square pyramid from the outside, or if I dip it in a bucket of paint, what surfaces get painted, I am not going to include the base. Without the base. So let's write out my surface area of a pyramid formula. 1/2 perimeter times slant height plus b, but I know I'm not including that b. So then I can plug everything else in. The perimeter of that base is 10 plus 10 plus 10 plus 10, so 40. And the slant height of that pyramid is 13. That gets me 1/2 times 40 times 13, I believe 260. And then I need to work on the surface area of that bottom shape. Again, we're thinking about them completely separately. So that bottom shape is a rectangular prism. It's a prism because it has 2 bases. These are its 2 bases. However, one of the bases is not included. So I'm only saying with one base. Go back to your surface area of a prism formula. It is perimeter times height plus 2b, but we're going to cross out the 2 because we only want one of those b's. So this is the perimeter of the base is 40 times the height is 12 plus 1 base, 10 squared. And I believe I get 580. So then I'm going to add them together to get my total surface area. 260 plus 580 is 840. Questions?